objective. By the end of this video, you will able to write linear classifier score, define decision boundary, and explain what hyperplane in simple terms. We are doing this because many machine learning classifiers work in same way. They compute a score from feature, then use that score to decide the class. I will use a simple example throughout this video, like pass and fail prediction for students. Each student has two features: study hours and attendance percentage, and the label Y tells us whether student the passed or failed. Y belongs to 0 or 1, like 0 we can consider for notation fail and 1 for pass. Define feature plus label, like a feature is an input number. This x1 and x2 we can call it as features. The label Y is the class we want to predict. Because we have only two features, we can visualize each student as a point on 2D graph. X-axis for study hours and Y for attendance. This blue area highlighting, this blue area we can say is like low attendance and low study hours. Whereas this white area is for high attendance and high study hours. There is possibility, like those students who come under the white box are like they have chances for pass, and those who are under the blue one like chances for fail. Now machine learning goal becomes very clear and mathematical. We want a boundary that separates passing students from failing students. Suppose this circle one are for the pass, the students who got passed, and the cross is for fail. And now we have to separate, so we can create multiple decision boundaries to separate pass and fail students. I'm trying to draw. Let me use different colors. Still there are few misclassifiers, and this yellow one is one of the good decision boundary. Now we introduce our key term, like first key term, score function. For defining score function, a score function is a formula that takes feature values and output one real number. The simplest linear score is weighted sum. Multiply each feature by weight, add them, and then add a bias. Weights tell us how important each feature is. Bias is a constant shift that moves the boundary. this score produces a number for every student. We turn that number into a class using a rule, decision rule. If the score is positive, we predict pass. If score is negative, we predict fail. The important thing is that the sign of score splits the space into two sides. Now we introduce the most important definition, that is decision boundary. The decision boundary is set of all points where the model is exactly undecided, where the score equals to 0. So, if the score is S W1 into W into x1 plus W2 dot x2 plus B, then decision boundary is this, equals to 0. In 2 dimensions, this equation represented by a line. Why this form? We like this form because it represents every possible straight line boundary cleanly without special cases. In school time, we gone through, we know that y equals to mx plus c. But what if my m is infinite, vertical line? So this case is not possible to represent with this line. Now we introduce term hyperplane. A hyperplane is flat decision boundary in many dimensions. In 2 dimensions, the hyperplane is line. So I am creating a table, a space shape, like 2D, it's a line. And 3D, it's a plane. And for n dimension or d dimension, like we can call it as a hyperplane. Why do we need this idea? Because in real ML problem don't have any two feature, like only two features. We have multiple features, 10, 50 or 100. But we still want a boundary that separate like pass or fail. In general, like D features, we write the same idea. We can compact in form of this Sx and W transpose into X plus B. To score X, this is compact notation. This is just short way of writing same weighted sum. So if we talk about summary, like we represented each student as a vector in full ML picture, and we computed the score. We predict the pass or fail on sign of the score. We created the decision boundary so we can separate and decide. That's all for this video. In